Welcome to Data Analysis Made Easy with Microsoft Power Tools, video number 2. And in this video, you are not going to believe it. We're going to see an example of all the different Microsoft data analysis tools. We'll see Excel, Power Query, the Worksheet, PivotTables, M-Code, DAX, Power Pivot, Data Model, Power BI Desktop, Power BI Online Services, and even Power Query in the cloud, Dataflows. Now, this is an exciting video because I'm going to show you each one of the Microsoft Power Tools and try to show you the situation where that particular tool is the best tool to accomplish the given data analysis task. Now, we want to see a worksheet solution, Power Query solution, a Power Query where we load the data to the PivotTable Cache solution. We'll see Power Query, Power Pivot, and a DAX solution. We'll see the amazing Power BI Desktop as a solution. We'll also see Power BI Online. And then we get to look at my new favorite Microsoft Power tool, Dataflows. This is Power Query. It's online Power Query, and you get 2 for 1 here because it's the get and transform data Power Query that we love, but it also becomes a data source that's universally available to everyone in your workspace and allows you to deliver a single source of truth data source. Now, when we have a data analysis task, the first question is, we want to say what are our goals or what do we need in terms of reports and visuals. For this example, we need a year-month sales report, something like this, and we need a product and region report that updates instantly when source data changes, something like one of these 2 reports down here. The next question is, hey, where is the data? Well, in our case, the data is already in the worksheet, and we don't have millions of rows that might require us to go use the data model. So here's the tools we pick. Pivot tables are particularly easy when we want to group year and month sales. So that's one reason to use a pivot table. The other reason to use a pivot table is if we have to calculate sales as a percent of yearly total, we can use the amazing Show Values As feature inside a pivot table. And then we're going to pick Worksheet Formulas because anytime somebody says, hey, I need the solution to update instantly, well, Worksheet Formulas are the only tool that does that. So the combination of the data is already in the worksheet and the reports we need are perfect for pivot tables and formulas. That's what we're going to do. Now let's click on the tab Worksheet. Now we have a fact table and 2 dimension or lookup tables. And if we're in the data model, we build relationships between the 2 tables. Or in Power Query, as we'll see, we could use the merge feature. But here, we can do our data modeling to look up product and price with the XLOOKUP function, and then look up region. We'll start it off by adding an extra column to our fact table to look up product name. Product, and this is an Excel table, so when I just type a name next to it, it adds a new column, equals XL tab. Our lookup value for product name is going to be product ID. This is the many side, comma. Lookup tables or dimension tables always have a unique list or a primary key, so we're going to try and find a match there, comma, the return array. We're trying to get the name. Now we're doing exact match lookup, so we don't need any of the remaining arguments. Not only that, but when you have a function like this, you don't even have to put close parentheses. I can just hit enter. Now, when I hit enter, the Excel table will copy the formula down to every row. That's different than spilling a formula, which we'll see in just a moment. So when I hit enter, sure enough, the formula got copied down. And you can tell it's copied down because in every cell, you can see the formula. We need a region column equals XLOOKUP. This time the lookup value is going to be sales rep ID. That's the many side. Here's the one side, comma, we're trying to get region. There's what we want to return and enter. We definitely need to calculate sales. In this column, we first have to go look up the price, product ID. We're getting a match there. And these are crate prices. So 1 crate of apples is 35 bucks. Right? So that gives me the price in each row, but in the top cell, F2 times, I want total sales, so whatever the price for the product is, times units. I don't think we're going to have any rounding problems, so we don't have to use the round function. And there's 1, 2, 3 helper columns. This is a foreign key, so is this. This is a calculated column that is calculating one of our facts that we want to measure or create metrics for. Now, I always tend to, when I build my models, especially when I'm not going to give them to anyone else, I want to make sure and visually portray that these are formulas and that the ones that don't have the formatting are raw data. So Control 1, I always use a special type of green, that green right there. That's the color of accounting paper that I used to use before I used Excel. So that's the special color I use to designate, hey, those cells have formulas. Now what we've done here is instead of building a data model with relationships, we actually took attributes like product and prices and brought them over into the table, and we created one flat table. And that is the type of table that's perfect for a pivot table. Now I'm going to click in a single cell and we'll build the yearly monthly sales report. We could go up to Insert, Drop Down, but keyboards rule because they're fast. So Alt-N-V, and I want you to notice something. T is what we're going to use because it's a table from the worksheet, but throughout the rest of the class, if we have a query that's connection only, we would do external. Later, we'll definitely be making data model pivot tables, so that will be our source. And later, when we publish a data model, either from Excel or Power BI Desktop into Power BI Online, it becomes a semantic model, and we can actually access it here, which we will do. So I'm going to tap T. It knows that that's the Excel table name. I'm going to put it on existing. That cell 04, click OK. And there's our pivot table. Here's our pivot table field list, and we have our row, values, filter, and columns area. Now, anytime you take a table from the Excel worksheet and create a pivot table, it actually takes the data and duplicates it and loads it into a behind-the-scenes location called a PivotTable Cache. That's one reason why when source data changes, as we'll see, we have to refresh, because when we refresh, we update the cache. Now, the first task we have is we need to take numbers at a transactional grain and roll them up into months and years. Well, the pivot table feature is perfect for that. This date column has individual transactional dates. But if I drag it down to the row area, watch what happens. It actually groups and gives us year, quarter, months. Now, I don't want quarters, so I'm going to click and drag it off. I don't want date. So I drag it off, right click, expand or collapse, and I want to expand entire field. And just like that, when we drag our sales, we'll get monthly and yearly totals. Now, in the pivot table cache, when we group, it actually creates two new columns for year and month. Now, this grouping feature did not always used to be automatic. If we right click, point to group, this is how we used to have to do it. We'd manually click the categories we want. Now, notice there's a bunch of different categories. Hours is great if you want to count the number of transactions per hour. We want months and years. I don't want quarters, so I'm going to click to deselect that, click OK. Now, I don't want this to be named year's date, so I'm just going to type year, tab, and then month, tab. Actually, let's click back in there. Now, we want to add sales by month and year. Now this is a number field, so when I drag it down to values, the aggregate calculation defaults to sum. In addition, because this is a pivot table, it's not like a DAX formula that automatically can have number formatting. Every time we drag a new field, we have to reformat all the numbers. Now, formatting a field in a pivot table is different than formatting cells. If you look through this right-click drop-down menu, there's no number formatting, but there is a format cells. And that format cells will format whatever cells you have highlighted. Notice all the different tabs. If you're in a pivot table, don't select that because it formats the cell. Select number formatting. That formats the field. And you can tell you're in the right dialog box because there's only one tab. I'm going to say number, comma. I don't need to see pennies. Click OK. Up at the top, I'm going to indicate the unit in the label. Now let's do something amazing. I want the percent sales for each month as compared to the yearly total. We drag sales down again. In this column, right click, and there's two different main ways to make calculations in a pivot table. Summarize values by, those are the 11 aggregate calculations. And when you go over to show values as, there's a bunch of calculating magic here, but make sure that the aggregate calculation is correct first, especially when you're counting and doing frequency distributions. Sum is what we want, so now we go over to show values as. And there's a bunch of great calculations. Next video we'll go through lots of these, but let's just see what percent of column total does. It does exactly what it says. Whatever total is at the bottom of the column, all the other numbers are compared using division. Now sometimes that's exactly what you want. Right click, show values as. That's not what I want. I want percent of parent total. Now when I click this, it's polite. It says, what is the parent? Year is the parent, so click OK. And that is beautiful. That calculation did each individual number compared to the total for the year. Down here also. Now that calculation in a pivot table is a lot easier than any of the other functional languages. We'll add a label at the top. So if you have your data in the worksheet, the pivot table has great advantages like the group by feature and show values as. Now just to illustrate one main difference between pivot tables and formulas, I'm going to come over to June 2025. I'm going to change the units to 5,000. Before I hit enter, look down here, there's June for 2025. When I hit enter, the pivot table cache, that data that is stored underneath, does not automatically update. No problem at all. Right click. When you click refresh, it's refreshing that pivot table cache. And sure enough, that updates. Now Control Z to undo the refresh on the cache. Control Z is undo. And then Control Z to change the raw data. And of course, formulas do not have that problem because they don't cache data. Formulas instantly update when source data changes. Now I went ahead and added some labels at the top, and we're going to build our report using dynamic spilled array formulas. Now before dynamic spilled array formulas, we built reports with formulas, but it was much more difficult, sometimes nearly impossible. And one example of nearly impossible is if you tried to create a formula for a unique list or to sort your formula, they were gigantic, cumbersome array formulas. In fact, I wrote a whole book about that topic back in 2012. But now Microsoft gave us these amazing dynamic spilled array functions. Now what I want is I want from the fact table a unique list of products. So we'll try unique. And I'm going to Control Enter. That put the formula in the cell and kept the cell selected. Now notice in the top cell of this spilled array is the formula. But if you arrow down, the formula is a ghost. It's all grayed out. And if you hit F2, well, technically there's really not anything in the cell until you type something. And then the formula up in the top cell is going to be mad because it can't spill. There's something in the way. Control Z. Not only that, but F2. Well, it looks like there's nothing there, but if you want to reference that cell, well, it has no problem. Control Z. Now there's a number of benefits of dynamic spilled array formulas as compared to legacy formulas. The first one, of course, is, hey, unique is a function that does something that we couldn't do before. The second benefit is, well, I need to edit this formula. In legacy formulas, you would edit the top cell and have to recopy it down. But watch this, F2. I want to edit this, and I want to add a second function so we can sort the unique list. And when I finish editing, I just enter or Control Enter, and the results automatically update in all the cells. Now, there's a third benefit to dynamic spilled array formulas. But before I show you that benefit, let me calculate this column, which is a conditional sales total for each one of the products. Let's do it the old school way first. We'll use sum ifs, sum range, There are the sales, comma, criteria range. We're looking through all the products, comma, and criteria 1. The old school way is we select a single condition and then SUMIFS is programmed to deliver a single answer. But what do we have to do? Close parentheses, control enter. We have to double click and send it down. Go to the last cell and F2 to verify that the references are pointing in the correct locations. But guess what? We don't have to do either one of those steps. Control Z, F2 in criteria 1 argument. Instead of putting a single item, if we put more than one item, in our case 5 items, that tells SUMIFS to deliver 5 answers, 1 for each product. Now look at that, T5 pound. Because dynamic spilled array formulas only live in the top cell of the spilled range, it can only refer to T5, and that pound is called the dynamic spilled range operator. That means always get everything from T5. Now when we control enter, the results spill. We didn't have to manually copy. Now we need a total here, so I'm going to type total, and then the keyboard for the sum function is Alt equals. And sure enough, it's smart enough to know that that formula only lives in U5 and it has the dynamic spilled range operator. Now, the fourth benefit of dynamic spilled array formulas, well, let's do this the old school way. We want to calculate the percent sales as compared to the total. Equals, well, the old school way was relative cell reference divided by the total, and every cell needed that total, so we had to lock it with the F4. Control enter, double click and send it down. Go to the last cell in F2. Well, it gives us the correct results, but we had to lock the reference and manually copy it. Control Z. Let's try this again as a dynamic spilled array formula. I'm going to highlight all the numerators, including the total, divide by the total, and when I control enter, bam! I didn't have to lock the reference and I didn't have to manually copy. Now let's add some number formatting. Control 1, percentage 1 decimal, okay. Control 1, number, let's use a separator and I don't want to show any pennies, okay. And there's our finished dynamic spilled array formula report. Now why in the world would we do it this way when a pivot table is much easier? Well, if we come up to the first transaction, I'm going to change the units to 5,000. That's for the product orange, June 2025. So we'll look at that number in the pivot table and that number right there for orange. When I hit enter, well, formulas, they instantly update, but the pivot table cache cannot update when the source data changes until we refresh. So if that's a requirement, formulas are awesome. Control Z. Now the last Microsoft data analysis tool I want to show you in the worksheet is related to a pivot table. Now notice when we create a pivot table, we start with a table that contains fields. Over here we have a field list. When we drag a field down to rows, what does it do? It gives us a unique list of conditions in the row that serve as the condition or criteria for making the calculations. Then we drag fields down to values. Here we dragged sales. That's because we want to make some calculation on the sales field. We also have the columns available for a cross-tab report. We could actually drag a column down here and there would be conditions across the columns. Here the pivot table is just saying, hey, I have multiple calculations across the columns. Now here's what I want to show you. There's a function called GROUPBY and PIVOTBY. These functions are in beta, which means they're not released to everyone that uses Microsoft 365 Excel, but they will be soon. Hopefully by the end of this quarter, they will be released so you can try them because these functions are game changers. They make a formula just as easy as a pivot table. Row fields. For this report, I want to do region, so I'm going to click at the top in the field name, Control Shift down arrow, Control backspace, comma, the values, we want sales, Control Shift down arrow, Control backspace, comma, the function, we're going to type in sum, comma, our data set definitely has field names at the top, so I'm going to put 3, which says, yes, we have field names and please show them. Close parentheses and watch this. When I control enter, With a single formula, we have a unique list, our conditional calculations, and a total row. Now, there is a problem. This function, at least not yet, hopefully Microsoft will fix it when it gets out of beta, it doesn't have a label at the top for the calculation. That's why I put this up here. Now, F2, we are allowed to have multiple calculations, but in the function argument, we have to use another function that horizontally stacks the calculations or functions called hstack. The first array, well, we'll do the sum calculation, comma. We want percent of, and so the function is called percent of. There you can see the f of x, close parentheses. When I control enter, that is just amazing. A formula did that. Now, I still am bothered by the fact that internally in the formula, it doesn't say what field are we making the sum and percent of. But no worries, I put that up at the top here. Now, what's amazing about formulas is, watch this, I'm going to come over and in the dimension table, I'm going to change Chantel's region to northwest. Now, look over here. When I hit enter, just like that, it updates. In addition, if I look up here, F2, I'm pretty sure that once I get the hang of it, I can create this faster than I can create a pivot table. And we don't have to deal with the PivotTable cache and the refresh that's required when source data changes. Now, I looked at GROUPBY. That only does row area, but watch this. PivotBy is another option, but I replaced GROUPBY, so you gotta be careful because the only difference between the two functions is that we have row and column. So watch this, I'm gonna skip column by typing a comma. So now row, that's region. Column, we don't have anything. Values, that's the sales column. And then we have our two functions. And sure enough, we are indicating that we have fields in our data set. Control enter, it'll give me exactly the same thing. All right, so hopefully these functions will be out of beta soon. Certainly dynamic spilled array formulas have 4 amazing benefits. And for both of these, the reason we use them is because we want everything to update when source data changes. And then over here, we did a pivot table, and the benefits are pivot tables are easy. Now for our next project, the goal is we just need to calculate average and standard deviation based on units by region. Now the data is coming externally, so we're going to use Power Query to import it into this Excel workbook. But the thing is, we don't need to load the data anywhere. We don't need a pivot table because we're not going to make multiple reports. This is all we need. So we can use Power Query for the entire process. Now in the source data folder that you downloaded, here's the Excel file. It has lookup tables that we need, and here's the text file. As we talked about earlier, a text file can deliver a table, and the structure is simple. Field names and bits of data are all separated by a tab. Now on this sheet here, that's where we'll put our eventual report. We want to go to data, get and transform, and right there, that's the from text CSV. So I'll click, navigate to the text file, click import. And in this text box, it gives you a preview. The file origin is perfect. Be sure and check the delimiter. It did guess right. And it asks whether you want to detect the data types based on 200, the entire data set, or do not. Almost always 200 rows is fine. Now we click transform data, not load. Transform data. That of course brings it into the Power Query editor. We want to rename our query. I'll call it sales TXT. Now here's the 3 automatic steps that were created. Source, if I select this, I can look up in the formula bar and there's that csv.document function. Files.contents got the file contents of that CSV file. And there's the hard-coded file path. That's called an on-premises file path. That means that if we move that file right there, that's the source data, then we lose connection and that could cause problems. We'll see how to deal with that various ways throughout this class. And notice down here that the headers are in the first row. That's because it's a text file. But Power Query knows how to interpret text files. So the next step is promote headers. And notice for every single new function or new line of M code, it'll almost always be acting on the previous step. So it says, hey, I'm going to transform that step by adding headers. And then finally, this step right here is acting on the previous step, and it adds data types. So the name of the previous step, it's called promote headers. That's the identifier for the output, just as change type is the identifier for the output of this query step. But what in the world is that pound in quotes? Why do we have to use that for identifiers? Because when you have an identifier, you're not allowed to have spaces. Now you would think that we could just use double quotes, but in M code syntax, double quotes indicate that something is text, not an identifier. So when they designed M code, they said, hey, if you have spaces, you have to have pound and quotes. Then we know it's an identifier. So our rule is going to be, we're never going to use spaces in identifiers. Now I want to rename this over in applied steps. So just like in Excel, F2 puts it in edit mode. And I'm going to call this just promote headers. F2, you can call it what you want. I'm going to call it add data types and enter. Now that is much easier to read. No pound or double quotes. Now the other thing we want to make sure that we do anytime we import a table is to make sure the data types are the correct data types. Now if you click this icon, these are the different data types you can have on a column. Date is fine. That little icon means a whole number. That one's fine for units. ABC, of course, is text. Text is fine for each one of those IDs. Now we finished this query, but when we finalize this as a report, we're going to need region, and that field is in the dimension or lookup table sales rep, and that's in an Excel file. So we need to create a new query. Now we're not going to load this one yet. We're going to go get the dimension tables, do what we need to do, and then we'll load. I want to go over to new query, new sources from file, and we want to go get 4 different dimension lookup tables from an Excel workbook. We'll navigate to that lookup table, click import. Now different than a text file where we have a delimiter tab, when you have a data source like an Excel workbook or a database with multiple objects, you get the navigator window. We want to select multiple items, and we want each one of these dimension tables. Now this is in Excel, and those little blue icons mean that's an Excel table. That icon means it's a worksheet. Now we're going to click OK, and notice it doesn't say transform data, because transform data is when you're in the Excel worksheet and you want to bring it into the Power Query window. We're already in the Power Query window. So when I click OK, we're going to create 4 new queries. Now the name for each query is fine. You want to go through each one of the 4 queries, remove the spaces, and check the data types. Now the data types are fine here. This says % discount, but I'm using decimal. Usually math calculations in Power Query, although you have the option for currency over in Power BI, this is called fixed. This actually gives you only 4 decimals, whereas decimal gives you up to 15. So I tend to do all my calculations based on decimal. The data types are fine. I remove the spaces. And of course, decimal is fine for price and cost. Remove the spaces, the data types are fine. Now, we are going to use sales rep, and we're going to look up region and bring it over into sales text. But here's the cool thing. This is Power Query, and this is a query that brought in a text file, but we're going to use this text file a few different times. So instead of basing our report off the original query, I'm actually going to close and load these all as a connection. Then we'll duplicate it and finish our report. So we want to go up to Home, Close and Load To. I'm using the drop down. If you click that button, it just dumps all the queries, each on a different worksheet. Close and Load To. We're allowed to load to an Excel table, the pivot table, the data model, but we want only create a connection. This is great when you have queries. You hold them up in the Power Query editor, work with them, and when you get the final result, then you load it somewhere like an Excel table or a pivot table. So click OK. So queries and connection pops up. Those are all the queries. Over in data, queries and connection, That button is a toggle, so when you want to see the queries, you can toggle that on. Now we need to duplicate this, and if we right-click, reference is exactly like a cell reference in Excel. You're just referencing the query. If that query changes, then the reference also changes. We don't want that. We want to actually duplicate the M code, so we're going to select duplicate. And we can see that it was duplicated. There's our 3 steps, including the identifiers with no spaces. Let's rename this. I'll call it something like Group by Report. Now we need to use sales rep ID as a foreign key to look up over into sales rep and pull the region. Once we get that, then we'll do a report on region based on calculations on unit. Now in the Excel worksheet, when you look something up, XLOOKUP. In the data model, we can use relationships or the related function, but in Power Query, we can use merge. So we're gonna click merge drop down. We don't want to create a new query. We want to merge and look something up in this query, so we'll select the top one. Now we'll learn a lot more about merging and joining later. This is called the top or left query. Sales rep ID, that's the foreign key. We want to look up in the primary key in sales rep ID. There's the primary key. The type of join, we get to study all of these later, but left outer is the most common. That's like XLOOKUP, lookup. All from the first, only matching from the second. So we'll click OK. Now I want to rename each step as I go. This is a merge join lookup, just to put all 3 possible verbs there. And here's the cool thing, if we go look at this column, it gives us a table, and because it's looking over to a primary key, it returns a single record with the primary key and attributes. Now the amazing thing is that allows us to look up multiple things at the same time. Let's click expand. Uncheck use original because I don't want that original name there. And in this merge, join, lookup, we're only going to look up region. Click OK. And there we have looked up region. Now the report we're going to need is we need a unique list of region. And then from the units column, we need to calculate average and standard deviation. Now that sounds like a pivot table, but in Power Query and in most database computer languages, we use the group by feature. Now to group by, we select the column that we want to extract a unique list from. In home, well, there's group by. Transform, there's group by. But since I always have to come over and select the column, I just right click and there's group by. We're going to use advanced because we want 2 calculations. We'll have average, units sold, that will be the name of the new column, the operation. Here's an aggregate function we get to choose from. Here's the column, units, add aggregation. We'll call it standard deviation, units sold. The bummer is up here in Power Query Group By, there's no standard deviation. Now I want to show you a great hack for when the function isn't here. We just select a placeholder sum. The column is units. Click OK. Whoa, that looks like a pivot table. Unique list and 2 calculations. Up in the formula bar. Well, we know for sure Power Query names functions smartly. Table.group, because what is it doing? It's taking the previous step, which is a table. That's the column where we're going to get a unique list. And then these are the 2 aggregations. Now this is called a list, which means curly bracket within a list. And it's a very clever M code syntax to allow for any given aggregate calculation for us to enter 3 bits of information, whatever the column name is, what the calculation is for each row, and the data type. So the first list has our average calculation, and the second list has our standard deviation, except for we have a placeholder. So I'm just going to replace it with standard deviation. I see it there, tab, click the checkbox, and bam, there's our standard deviation. So we created, using Power Query, our report, a very basic report based on our external data. Now we can close and load to, and I definitely want it on a table, existing sheet, okay, and there's our report. We took that external data, ran it through Power Query, and got exactly what we wanted. Now the next data analysis task, we need a sales and cost report in the worksheet, but we don't need the table of data in the worksheet. Now where's the data? It's actually from the previous query. And instead of creating that query again from scratch, we'll just duplicate the query. And because we don't need the table of data in the worksheet, we'll actually create the calculated columns for sales and cost right in Power Query, and then we'll load it directly to the PivotTable Cache. That way we can make our report with a pivot table and take advantage of the show value as percentage calculations. Now right over here in queries and connections, this is the source, so right click, duplicate. I'll call this PivotTable Cache report. Now the first thing we need to do is with product ID, we need to merge to go and get price and cost for each product. So we'll merge. The top or left table is our sales table. There's the foreign key, product ID. Here's our lookup table or dimension table. Primary key, join kind, left outer, click OK. Now if we look, and when you look at what's in a cell when there's a table, don't click the green thing because that'll extract the table. But we can look here, there's the primary key, and guess what? We're going to look up two things at once. So we click expand, uncheck, and we just want cost and price, click OK. Now we need to multiply price times units and then cost times unit. And one of the most amazing things about Power Query is it'll write most of the formulas for us. So watch this. We're going to click create price, scroll over, hold control, click units, go up to add columns. Custom columns, we'll have lots of fun with that later. But look at this, from number, standard, and there's a multiply. And sure enough, it added a column and multiplied the two fields we wanted. Now, table.addColumn, that's another great name for a function. Oops, I forgot to take the spaces out of the previous step. I'll be sure and do that. Multiplication, well, that's the name of this column, and that's not a good name. We'll call this sales. And for each row, there's the calculation, and it added a data type. And there's our sales. We'll do the same thing, cost, units. We'll multiply. We'll rename the column. And just like that, we added two helper columns. Now, I forgot to do something. When we looked up cost and price, that would be this step right here. I forgot to look up the attribute product. Because over in the pivot table, I definitely want product. Well, here's another beautiful thing about Power Query. It memorizes all the steps, and we're allowed to go back and edit. So let's go to lookup price, and when you see a gear icon, you can click to open up the dialog box. And sure enough, I can check product. And now instead of looking up two things, I'm going to look up three things. And there it is. Now sometimes when you edit a step, it might hurt subsequent query steps, but not in this case. We get to the end and we have exactly what we want. Now the last step is we need to remove the columns we don't want and keep the columns we want, because those are the columns we're going to load to the PivotTable Cache. And here's a great trick. We want to very carefully select the columns in the order in which we want the columns to appear in the final table. Date, scroll over, I'm holding control, product, back over, the third column will be units, and then sales and costs. Right click, remove other columns. And just like that, it removed the columns we don't want and ordered the ones that we do want. Now we're ready to load this. We'll go to close and load to, and we're going to load it to the PivotTable Cache. I want it on this existing worksheet. Click OK. All right, for our product sales cost report, I'm going to check product once, units, sales 1, and I can't check again, so I'm going to drag it down below, and then costs and drag it a second time. For the second sum, right click. We're going to check if it's the correct aggregate. It sure is. And then please give me percent of column total. Same with the last column for costs. And sure enough, after renaming the columns and adding number formatting, we have our report. We took external data, imported it using Power Query, did our transformations by adding extra columns using the automatic formula feature inside of Power Query, and then load it to the PivotTable Cache. Now, one thing that's annoying to me about pivot tables is every time I drag the same field, I have to retype the label and add number formatting. Well, with DAX formulas in a data model pivot table, you don't have to do that. And that's our next example. Now, before we go build DAX formulas in the data model, I want to do two more things in Power Query. Let's double click this PivotTable Cache report query. I have this query selected, and we talked about the two places that we can edit M code. We can definitely, in applied steps, edit the identifiers. We already have edited a few times the M code up in the formula bar, but there's a third place. Let's just take a look, and later in the class we'll learn how to edit up here. Let's click Advanced Editor. Here are all the steps that we created for this query. A query uses the let expression. The let keyword is always followed by the steps or the variables that we create. Subsequently, each new variable can use the previous variable. Then the keyword in, whatever you put after that, that's the output from the query. It's almost always the last step. Click Done. So for each one of the queries, we can click Advanced Editor and look at the let expression. Up here, Sales Text, Advanced Editor. Here's that first step we looked at, and there's the on-premises file path. And the second thing I want to show you is what happens if we move this file. Click Done. We'll click Close. Now here's my TXT. This is the path that I have. I'm going to cut it with Control X, and I'll put it on the desktop, Control V. Now if we go back over to our Excel file, remember that query is used in multiple queries. If I come down to Group By Report, right-click Refresh, or there's an icon right here, or you can come over to the query and right-click Refresh. We get a data source error, could not find that particular path. Now here's the query, and you can fix this error in three ways. You can go to the source step, click the gear icon, and you can use the Browse button to go and find the new location for the file. You can also just edit in the formula bar, but the best way to change it is to find data source settings either here in the Power Query Editor or in the Excel environment. Get Data dropdown, Data Source Settings. We select the file, click Change Source, click Browse, browse to the new location, select the file. And when you click OK and close, now when we click Refresh, now the output from the query is again connected to the data source. Now if you're in Power BI Desktop, Home, Queries, drop down for Transform Data, and there it is. Up in the Power Query Editor, the button is right there. Wherever you find it in Excel or Power BI Desktop, it's a common error to have a file move, and you need to reconnect your file to the source data. All right, example number 4. Well, our goal is to create a product report with average daily sales calculation. Now, we can definitely do that in the worksheet, but it's a multi-step process. So I'm going to choose to do it with Power Pivot, the data model, and DAX. Not only that, but when I have a star schema data model and I create this average daily sales, I've created one formula with formatting, and I can drag and drop it into lots of different reports. Now, the fact table data in this example comes from a JSON file, and it doesn't come with a table structure. It comes with a record structure. Not only that, but the lookup tables that we're going to load to the data model along with the fact table, they're already loaded up into Power Query. So in the Excel file, data, get data from file, and we want JSON. Now up in the formula bar, we can see JSON.document and file.contents and our on-premises file path. Now luckily when we do this, it comes up in Transform, and we can come over and go, a list of records to table. So I'm going to click, select the delimiter. We don't have one. We don't need to handle errors. Click OK. Now if we look in each row, we can see sure enough there's a record. Now we can use the expand button. I do not want the original column that says column 1, but I do want all those columns. Click OK. Now the table doesn't have data types, so I'm going to select the first column, hold Shift, click the last one, go up to Transform, and most of the time Detect Data Types does a good job. So we'll click. So date, whole number, text, and text, so we're looking good. Now we want to load this fact table to the data model. So we'll go up to Home, close and load 2, and we want only create a connection and add this to the data model. Now, I've been teaching a long time, and virtually half the class the first time they try to load something to the data model for the first time, they forget to uncheck table. So uncheck table, and then click only create a connection. Click OK. Now you can see the query down here, and if we hover, you can see it says loaded to the data model. We can go look in just a moment, but guess what? We need to send all of our dimension tables over to the data model. Well, they've already been loaded as connection only, so I'm going to select D customer, and anytime you want to change the load location, you right-click load to. Well, it's already got only create a connection, so now I'm going to say add this to the data model. And get this, that query is being used by other queries up there also. But now we're going to send it to the data model also. The actual data will be loaded. Click OK. Now do that for each one of the dimension tables. Now once we've loaded all the tables to the data model, we want to work in the Power Pivot window. If you go to Data, Data Tools, there's the button. That'll open up the Power Pivot window. Also, you could go to the Power Pivot tab. However, you probably don't have this enabled. The first time you click this, if you don't have Power Pivot enabled, it'll ask you to enable it, and you say yes. If you have it enabled, you can certainly come over to Power Pivot Data Model and Manage. Both buttons jump to the Power Pivot window. So let's click, and just like Power Query that opens in a new window, so does Power Pivot. Now we have a couple different views here. We're in Data View. That just means the tab's down here, and we can click to view a preview of the data. Remember, when we load to the data model, these tables are loaded into the columnar database, which compresses the data into a smaller size. Not only that, but the DAX formulas and functions that we use work efficiently with that columnar database to make calculations over big data. Now notice the table preview is up here. Down here, this is called the measure grid. If you come up and click calculation area, well, that goes away, and you can see the full table. Now, calculation area is important because this is where we'll build our DAX measures. Now, let's go look at diagram view. Now, here's a preview of the tables we loaded into the columnar database. Now, the model that we're trying to build is a star schema data model, and that means we're going to have the fact table in the middle, and we want our dimension tables surrounding the fact table. The positioning of these tables has no effect on the performance, but it's easier to see fact tables surrounded by dimension tables. Now, in diagram view, this is the easiest place to create relationships, and later we're going to have to hide columns that we don't want in the reporting area. Now, let's create the relationships. I'm going to start with date. This is the one side. Drag it over to the many side. And we can see our one-to-many relationship, 1 to an asterisk. Now we're going to drag sales rep ID over to sales rep, customer ID to customer ID, product ID to product ID. Now relationships help a model like this in 3 main ways. If we need to do a lookup, like to go get price, we get to use an amazing and simple lookup function called related, which we'll see in just a moment. The second way that relationships help is we can drag attributes, customer, product, from the dimension tables, and it slices and dices our reports and visuals. The third benefit we'll talk about later is called filter context. And if you drag customer to a pivot table or a visual in Power BI desktop, for each row in that pivot table or visual, when you hit a particular customer, this table is actually filtered down to a single row. That filter flows across a relationship, and it filters the fact table down to just the records for that customer. And what does that do? It helps your formula calculate over big data more quickly. Now, step 1 in building a data model, well, we use Power Query to transform and import it. Step 2 was relationships. Step 3 is building our formulas. So we want to go over to Data View. Now, over here in Data View, we can select whichever table we'd like to create our measures and other formulas, but we're going to pick the fact table because what do the measures do? The measures are metrics that measure some fact in the fact table. And since whatever measures we create here will show up in the field list under the fact table, that's what we're going to do. That is the convention when you're using a data model. Now that we've talked about calculated columns and row context, now we want to talk about measures and filter context. Now, our first goal is total sales, and I'm going to show you two different ways to do it. If you already have a calculated column with line sales, then we can just use the sum function. When you create a measure, you'll have to create the label that shows up in the field list, and then the assignment operator, colon, equal sign, and then the formula. Now let's type total sales, and notice it shoots me up to the formula bar. And I'm going to call this the two-step method because we're going to use the sum function as the second step. And of course, the calculated column was the first step. Over here in Power Pivot, we have to use colon, equal sign as the assignment operator. In the worksheet, it's equal. Over in Power BI, it's also equal. Then we type our formula. So sum, and I'm going to highlight the column. You can't do this over in Power BI Desktop, but in Power Pivot you can. Close parentheses and enter. Now let's expand the column. And that's the grand overall total for this entire data set. Now remember, that's the name that shows up every time we use it in a pivot table. And we can also come up and add formatting. I'm going to show 0 decimals. That formatting shows up everywhere. Now, filter context. When I drag this into a pivot table, it's only going to say 5,169,178 in the grand total cell. In each row, it'll show an individual amount based on the conditions and criteria. And watch this. This is the measure grid. If I want to come up to customer and filter this actual data set, I'm going to say SFM. Watch what happens to the total here. Bam! Instantly, it shows me the total just for SMF. And that's filter context. Notice I filtered the table, and the formula updated. Now it gets better. Over in a pivot table or visual or in Power BI Desktop, when the condition in the row hits the measure, the actual fact table filters down to just the condition. And that means the fact table is a smaller size than it was if it had all rows from the original data set. And it's only then that the formula makes the calculation. And that's one of the clever ways that Microsoft got the columnar database, the data model, and DAX to calculate over big data more quickly. Now, I just illustrated it here. I am going to unfilter this. And there it is. Now, before I show you the spectacular sum x and average x, let's go use this in a pivot table. Now, I have a cell selected here, and let's use our keyboard, Alt-NV. And notice now there's a D for data model, so D. I'm going to put it on the existing, click OK. Now, in a data model pivot table, the field list shows multiple tables, and we can drag and drop attributes and measures. If we scroll down, these are Excel tables listed over here in the field list. But the tables we want have the little orange cylinder. That means they were run through Power Query and loaded to the data model. Now let's select Customer. I'm going to check Customer. There it is, a unique list. Now for our fact table. By the way, we're definitely going to hide these columns later because if you leave them here, they will cause trouble. And there it is. There's our measure. I can check. And there you go. That's the customer that we selected in the measure grid and filtered. But right there, it's the same formula in every cell. But that condition actually flows into the dimension table. The dimension table is filtered down to just this row. It flows across the relationship, and that's how the fact table gets filtered down to a smaller size. That's called filter context. Later in this video and other videos, we'll learn about the amazing calculate function, which can change the filter context. Now, back in the data model, here is the moment of truth. Here is the beauty of DAX formulas. Notice we have a table. We have a formula that's attached to the table, and then we summed. Well, if we create our second measure, and I'm just going to call this total sales because this will be the one that we use all the time, colon, equal sign, and we're going to use the great function sum x. Now notice it has two arguments, table and expression. Expression is a synonym for formula. Well, what did we have over here? We had a table and a formula. So whatever we did here, well, this is the fact table. And whatever we did here, whatever that formula was, we just throw it into SUMX, and it simulates this column. That's the X part. That's the iterating part. And then the sum adds. So we'll type the name of the table. I see it there, tab, comma, and the expression is the exact same formula we created. Related, D product, there's the price, times, and we want the units column. Now, just as over here we had row context, this formula is going to have row context. It's actually going to iterate down the entire sales JSON table. The related function has row context, so in every row, it'll see the correct lookup value. And then units, every single row, it'll pull out the correct units. Close parentheses and enter. Now I'm going to click Save. And just to show you that this works without this column, I'm going to come up here and right-click Delete Column. Yes. Well, there it's gone. There we get an error. But no problem. SUMX simulated the table and the helper column and gave us the total. Now I went ahead and closed it and opened it. And because I saved it, that is there. I'm going to leave the calculated column and this first measure as a trail. And that is an option. But certainly most of the time, people just go straight to SUMX. Now, there actually is a trade-off. There's a benefit to each and a drawback to each. The two-step method, the drawback is that this column becomes part of the columnar database. And so if it's huge data, maybe it increases the size of the in-RAM database and slows things down. The benefit to this formula is when you drag this measure into a pivot table or visual, it doesn't have to internally iterate and calculate every value in every row. Whereas the SUMX, it certainly is not storing anything in the in-RAM columnar database. But every time you drag and drop it into a pivot table, it actually has to calculate every value. Not only that, but if you start changing filters and conditions, every time you do that, it has to recalculate the answers. The columnar database and the data model and DAX are designed to deal with this. And as the great Marco Russo and Alberto Ferrari, the DAX masters, say, until you get to about 100 million rows, there's usually not a performance difference. So the convention is definitely SUMX. Now, my rule of thumb of when to switch away from SUMX or average X and back to some calculated column is if I'm taking this measure and dragging it into a visual or report, and it's taken a long time to calculate, then I use the two-step method. So the calculation runs quickly in the reporting area. Now, the next measure we want to create is for average daily sales. And we'd like to just take an average of this column here. But if we did that, we would get average transactional sale. The grain on this table is for transaction. If you look over here, we have duplicates for 1, 3 of them right here. There's probably lots more. Now, one way to solve this problem is to actually add all of the daily sales totals first. And then from those numbers, we create our average. Now, we'll create an average X formula here. But before we do that, I want to jump over to DDate and simulate the logic of how the formula is going to work. Now, in a date table, what is the grain? It's day. So if somehow we could get the total sales for each day, down here we could just do an average. Now, let's try this. We're going to come up to Add Column. And I'm going to type day sales or something like that. And up in the formula bar, we're going to try to calculate total sales in each row. But we are going to get into some trouble. I have the sum function, and I want to get line sales. Now, there's a problem because this needs filter context to see this date. So when I hit Enter, there's no filter context in a column. Only row context. So that's the grand overall total. But there's an amazing function called calculate. There it is. And it does a couple things. But all we're going to use it for right now is it can do context transition. That's just a fancy way of saying calculate will take the row context and translate it into filter context. So calculate says, hey, I see that 1, 1. I'm going to bring it in, filter the fact table for just the sales for that day, and then sum can do its job. Now there's 2 arguments, and we'll have lots of fun with this later. But if you just use the first one, it does context transition. When I hit Enter, those are the daily sales totals. Now there's definitely some days where we didn't have sales. And conveniently, it shows a blank instead of a 0. So we can just come down here and calculate an average. But I got to show you something else. Notice we did calculate and sum. Well, back under the fact table, we already created a measure for total sales. So back here in date, I'm going to try something different. I'll call this column day sales with measure. And this is the first time we're going to use a measure in another formula. And the convention is you type a square bracket. There it is. You don't put table name in front of it, just square brackets. And watch what happens when I hit Enter. Remember, this is a measure. So I hit Enter. Whoa, the same exact thing. Well, Microsoft programmed all measures to have a hidden calculate. And that's specifically so that row context can get translated into filter context. And that really is the magic behind the formula we're going to see just in a moment to calculate average daily sales. Now let's see if we can get the average down here. So average daily sales, we'll just use average. I can pick either one, close parentheses, and Enter. And that is, in fact, the average daily sales. But instead of having to do it in a multi-step way, we'll come back to the fact table and create our measure here. Average daily sales, average, and there's an X. Now, what was the table that we just iterated to get a day grain? D date. So we'll use that in the table argument. And what's the expression? Well, we're going to use our lovely measure, which is a measure and has a hidden calculate and knows how to do context transition. Because remember, any formula in one of these X functions iterates to make a calculation. And because it's a measure and it does context transition, bam, that day's going to come in, filter the fact table, and average X will actually calculate a total sales for every day. And then that's the X part. And then the average will do the averaging. And sure enough, we get the same amount. Now there's 2 things we have to do before we can create our reports. Let's go over to diagram view. We need to hide columns that we're not going to need over in the reporting area. Now in the fact table, we do not want any of the foreign keys because the attributes should come from the dimension tables. Also, we do not want number fields because if you drag a number field into a pivot table or in a visual in Power BI desktop, you get an implicit measure. And there's some problems with that. I'm going to leave one here and drag and drop it and show you. To hide, right-click, Hide from Client Tools. We definitely don't want these helper columns or the measure from the date table, so right-click, Hide from Client Tool. And month number we don't need, but I'll show you why we have it there in just a moment. And then you can hide the remaining columns that we don't need. So I've hidden all the columns we don't need. Now we actually have to go back to Data View, to the Date table. You can see how it's all grayed out because they're hidden. And we have a problem with month if we drag and drop it into a data model pivot table or in Power BI visuals. The months will sort alphabetically. April will be first. Now, in Excel, there's a hidden custom list that always forces months to be sorted correctly. But in a data model, you select the month. And that's why we have month number, because 1 is associated with January, 4 with April. And so we'll tell it, hey, sort by month number. Click OK. Now let's jump over to the workbook. I added a worksheet called Data Model. Now let's use our keyboard, Alt-N-V, but instead of T, now we have a D, D. But let's start out. We're going to create a product report. And then down here, fact table. I meant to hide that one, so I'll have to go and hide that one. But 1, 2, and look at that. There's the beautiful labels and the beautiful formatting. Now let's see what happens if I check line sales. Well, it looks like we get the correct totals, but the name isn't very nice, and there's no number formatting. And if we go look at the data model, and all measures are supposed to be here in the measure grid, but where is the one we just created? Well, it's called an implicit measure. And if you go over to advanced, Microsoft does not have this on by default. When I click, then I can see this very inefficient measure. It's grayed out. I can't edit it. I can't add number formatting. And it won't show up in the field list to drag and drop multiple times. And there's also other problems. But the rule is, let's just not create implicit measures. We could also hide over here in Data View. Right-click Hide from Client Tool. I'm going to hide this one too. I'm going to leave that one showing. And the fact table's been converted to just a list of measures. And I don't see that implicit one. It's down here. I'm going to drag it off. Now let's create another pivot table. Alt-NVD, Enter. I'm going to do a customer, both measures. Click here, Alt-NVD, Enter. And we'll do a year and month. And there's my lovely measures. Every single time they have the correct name and the correct formatting. And we can see here the average daily sales for March 2024, 10,708. 9,426 daily average sales for the year 2024. We imported our data with Power Query, created our relationships, our measures, hid the correct fields, and bam, our data model is ready. Now we're going to jump over to Power BI Desktop and create the same data model and look at interactive visualizations. Now, Power BI Desktop is an amazing free download from Microsoft. You probably have it from the prerequisite classes that you took. Here's the address. The address is also in the syllabus. In this example, we're going to use Power Query to import the same data, but the fact table is coming from an XML file. We'll build the same data model and then build our interactive visualizations. Now I opened a blank file. I'm going to click Report. Before I do anything, I'm going to hit F12 to save this. I saved it to the same location where I'm saving all the other files. I gave it that name. Click Save. As we saw earlier in the class, when we import an XML, it actually has a complete table structure, unlike the JSON file in our last example. Now, much of what we do in Power BI Desktop is the same as over in Excel when we use Power Query and build a data model. Now, here's the Home tab, Data. And if we want to import an XML, get data. I don't see it, so I come down to More. There's my XML. Click Connect. Select your XML and Open. Because XML files can have multiple tables, we see the Navigator window. We select our transaction table. Click Transform Data to open up the Power Query editor. Now, this is Power Query and Power BI Desktop, and there's a few buttons in different places, but otherwise, the M code is the same. I am going to change the name to F Transactions and remove the spaces from the identifiers. And one thing that is different, Close and Load, that's Excel. Close and Apply, that's in Power BI Desktop. When you use Close, that closes the editor. When you click Apply, that applies the query steps and loads to the only place it can load, the data model. So we're going to click Close and Apply. Now here's Report View. We'll come back later and build our interactive visuals. Here's Table View. There's the table and some fields. This is our Model View. This is where we can create relationships and hide fields. And this section is new. This is DAX Query View. You can run a query against the data model. And we'll definitely check this out later in the class. So far, we have F transactions, but we have some lookup tables. So we go to Data, Excel Workbook. There's our lookup table. This navigator is the same as over in Excel. We're going to transform data. Now for each table, make sure the data types are correct and remove all the spaces from the identifiers. Now we're going to load all of these to the data model. So we click Close and Apply. Now in Model, they actually added some of the relationships already, although the date table doesn't have one. So we'll drag Date over to Date. Now we want to go over to Table View. and find the D date table. Over here, we want to mark as a date table. This will prevent hidden date tables from being created if you accidentally drag a date field from a fact table into a visual. We're going to turn this on, and the column is date. Click Save. Just as we did in Power Pivot, we got to sort month by month number. And we want to choose year, and it says summarization sum. So if you check a checkbox and send it to a particular visual, sometimes it adds the years, which is never what we want. So I'm going to say don't summarize. Now, if you'd like, we can format a date column. It's not going to have any effect on reports, but it will change how it looks in the table. Now, we can definitely create our measures in a table, but I like to do it in report view. Because whereas in Power Pivot Measure Grid, you can create your measure and see the result, you can't do that in a table. But in report view, we'll use a card or a visual. And as we create our measures, we'll drag and drop them into the card or visual to check our work. All right, we want to rename this page something like Check Formulas and Enter. Now let's click in the white. Here are the visualizations. We're going to use a table, so I'm going to click Table. We'll resize it. Actually, we're going to have a few different formulas. Now with the visual selected, let's come over to D product. I want a condition, so we're going to click the attribute product name. That's annoyingly small, so we can come over to Format, down to Values. We'll change the font maybe to 16. Down to Column Header, maybe 16 too. That's a little bit better. Now let's go look at F transactions. I've already created 3 measures, and I want to check. Total sales 01, cost of goods sold 01, and average daily sales 01. Then let's select total sales. That's the exact same formula we just made a moment ago over in Power Pivot. Cost of goods sold, we did not do this one, but the only difference is I used cost instead of price. And then our average daily sales, that beautiful average X formula. Now, I want to consider 3 different ways of creating these formulas. And if we go back over to Table View and think about how we calculated total sales, we had units, and we looked up over to the product table, got the price, brought it back, and then we had to iterate over every single row. Or inside of SUMX, we still had to do the same number of iterations. Now, this table only has 1,000 rows. But if your fact table has a lot of rows, 100 million, 500 million rows, that is a lot of rows to be iterating. So if we can think of a different way to get total sales, which is units times price, that doesn't iterate as much, the formula would calculate more quickly. If we go to Product, notice here's the price that we looked up and brought over to the fact table. But since total sales is always going to be units times price, what if we had total units for that product? Multiply it by price, and then that would be the total sales for that particular product. But the key is, when we add them all up, of course, we're going to get total sales, but we'd only have to iterate 5 times. Now, in F transactions, through the relationship, we can go look up and bring back the price. But over in the product table, we'd run into the same problem we ran into in the date table. If we use sum to get total units, every row would have the grand overall total. But the calculate function will come to our rescue. It will do context transition, taking row context and converting it into filter context. And then we'll have total units for each product. We'll first try it in the D product table. Let's go to New Column, Total Units by Product. And of course, if we use the sum on units, close parentheses, and enter, well, that's the grand overall total. But we're going to convert row context into filter context. Remember, the row context here is for Apple. We want that condition to flow in and filter the fact table down to just Apple. So calculate to do context transition. Enter. Now there's the total units for each product, but we really want total sales, so we simply multiply. Now in Power Pivot, I can just click to get the column, but here I have to type it out. There it is. And when I hit Enter, That's the total sales for each product. To create a measure, remember this is the two-step method. Create a helper column, right-click measure. I'm going to call this total sales 03 and then sum of D product. And I mislabeled that. That's not total units by product. It was for a second, but when I enter, I'm going to add some formatting. And I do want to rename this. Names matter, so total sales by product. Now let's go over to report view. Here's our report. And there's a measure. We don't usually have measures in a dimension table, but I'm going to check it. And look at that. We get the exact same amount. Now, later in the class, we'll actually time DAX formulas and see that there actually is a difference. But over here in report view, go to transactions, right-click, new measure. We'll call this total sales, and there's sum x. What is the table we want to iterate over? D product, 5 rows, comma, the expression. Well, one of the things we need is the sum of F transaction units. But of course, that is going to give us a grand total in every row. So calculate comes to the rescue. Actually, calculate always changes the filter context, and we'll see other ways that it changes the filter context later. But here, it's just saying there is no filter context. So I'm going to take the row context and turn it into filter context. That'll give us the total units for each product times D product. And this is a column from within the table we're iterating, that lovely 5-row table. Close parentheses. And when I hit Enter, add some formatting. Now we can come over and check. And sure enough, we get exactly the same number. But that formula should calculate more quickly. Now in the fact table, we're going to create total cost of goods sold. And it's exactly the same formula, except for at the end, we are not going to multiply it by price. We're going to use cost. Close parentheses and enter. Add some number formatting. And now we can check our measure. And sure enough, we get exactly the same number with a formula that almost certainly calculates more quickly. Now the next measure we want to create is gross profit. That's just the difference between total sales and cost of goods sold. Right-click, new measure. So what is it? Total sales minus total cost of goods sold. We're putting measures into other measures, so we use a square bracket only. We're using the $1 minus square bracket and total cost of goods sold. When I hit Enter, we'll add some number formatting, and then come over and check our gross profit. And there it is. Now, the last formula we're going to create, well, we're going to redo average daily sales, but we're going to do it in a different way. Instead of iterating over the date table, we're going to think about, well, what is an average? It's just add them up and divide by the count. So what that means is we want total sales for whatever the current filter context is, that's the measure, and just divide by a unique set of dates from the F transaction table. Well, we can definitely do that. F transactions, new measure. All right, so we have average daily sales, and we're going to divide. Since we're in DAX, we have a special function called divide. Now, the difference between just using the operator divide is that if we get a divide by 0 error, divide will by default show nothing, or the last argument lets you specify what should go there. All right, the numerator, we're going to put total sales, comma. And we get to use the distinct count function. And because we have a columnar database that keeps everything stored in a unique list, this function is fast when it calculates. So distinct count on what? F transactions date. And so now wherever the distinct count is in the filter context, it'll just know to count only the unique dates from the F transaction table. And of course, total sales will be in the numerator. So close parentheses, enter. Add some number formatting. We'll check our measure. And sure enough, we get exactly the same result with a slightly faster calculating formula. Now for the formulas we created in Power Pivot and the ones we created here in Power BI Desktop, unless you have big data, the performance for the different formulas will be very similar. Now for the last step in our data modeling, in model view, we're going to hide columns. So month number we don't need, so hide in report view. And we get a little eyeball with a line. Now let's close these, and you can hide all the ones that we don't want to see over in report view. Now I hid duplicate measures. I only kept the ones with the $sign. And then I hid the formulas we created in the D product table. All right, next we want to create a tab and try and create this product tab. Report, or as I like to call it, a dashboard, even though Microsoft has a specific location online for dashboard, because that's what it is. We're going to analyze product. Here's customer information, here's region, and here's time. All right, in report view, we're going to click and add a new sheet. We'll call it something like product dashboard and enter. Now, when you're visualizing quantitative data, you always want to try and pick the visual that will best articulate your message. That's rule number 1. And rule number 2, as Edward Tufte says, no chart junk. That means you only have elements in your visual that help deliver the message. If they don't help deliver the message, delete them. All right, we're going to click in the white. We want to show how sales change over time, and the perfect chart for that is the line chart. We'll resize it, move it down to the bottom. For the X, we will use year and then month below. For Y, we want total sales. And there we go. We can clearly see the up and down. The overall trend doesn't look like it's changing over time, but there's definitely volatile up and downs. Now, let's hover. That's called a tooltip. Let's check out something awesome in Power BI Desktop that Excel does not have. Hey, there's tooltips. I'm going to drag cost of goods sold, gross profit, and average daily sales. And now that's what I call a tooltip. Hover, and you can see for that particular time, those are the values. And if you think about the measures under there, at this point in time, there is filter context going on to get those numbers. The fact table is filtered down to just dates in July 2025. Now we want to look at our visualization and see if there's any chart junk. This is ridiculous. I don't know why they have that as the default. So we're going to go over. This is where we can drag and drop and create visualizations. Here's where we format. Now, if you're not used to Power BI Desktop, it does take a while to figure out where everything is. General. There's title. Let's open. I'm going to select everything and call it something like sales by month and enter. That's much better, less cluttered. Now, I think that this kind of chart is self-evident. We can definitely see this is a time variable on the horizontal axis. And I think sales are implied from up here. So we'll go over to Format, Visual. We'll look at X, scroll down. And right here, we do not want a title. There, it went away. I'm going to collapse and then go to Y. We'll get rid of the title, but we definitely want the values here. Now the line chart is done. Let's add a slicer. Click in the white. This is the old slicer. They have a much better slicer now. So I'm going to click. And we want product, so check. There's our slicer. It's too big, but we'll change the size later. Let's go over to Format, then down to Layout. And we want Arrangement, Single Row. And I definitely want to show all 5. Now let's resize the slicer. And notice when we hit the edge matched up with something else, that red line helps us align everything up. Now let's go find buttons. Oh, buttons are right here. And maybe some fill. Let's try a light blue. Now let's click in the white. And our next goal is to compare total sales and cost of goods sold across customers and across region. Anytime you're comparing the difference between values or values across categories, the perfect chart is the column or the bar. Now we need 2 more visuals, one for customer, which gives us total sales and cost of goods sold, and one for region. Now when you're comparing amounts across categories, you either use a column chart, which is vertical bars, or a bar chart, which is horizontal. The real difference is that horizontal sometimes emphasizes differences more forcefully because it's usually longer than it is tall. Now, because of this confined space, I am going to use a bar. We have the choice between stack bar, or clustered. We'll look at the difference in just a moment. There's for a column, stacked, clustered. Let's click clustered bar. I want customer in the vertical axis. And let's do total sales. We can resize. Now this clustered bar has a single measure, a single number plotted. If we change this to stacked, watch what happens. Nothing, because there's a single variable. Both of those charts are exactly the same if you have a single number. Back to clustered, we'll add cost of goods sold. When you use clustered, the emphasis in comparing differences is on the variable in the legend. We can clearly see the differences for each total sales and total cost of goods sold. If we change this to stack bar, now normally we have a categorical variable in the legend here. But we can make the point. When do you use stack? It's when you want to emphasize this variable here and compare the differences across that variable. Now let's go back to clustered. And now let's remove chart junk. Taking a closer look, we can see a lot of chart junk. Look at that. Total sales cost of goods sold, 1, 2, 3 places. Now, I think I'm going to keep it here because I like the color coding. I'm definitely removing it up in the title. General, title, and how about just customer? Well, if we have customer in the title, we don't need it as a label. So we'll come over to Visual, Y, down to Title, and we'll turn it off. For X, I definitely don't want that title. That's unnecessary repetition. Now, we have a choice with numbers and detail. If we leave the horizontal axis with the incremented numbers, that means the chart is much less cluttered. But we could come over and add data labels. Now, if you add data labels, you can't leave them in both, or in general, it's not a good idea because it's unnecessary repetition. But if you choose data labels, you're choosing more detail over less clutter. If you choose the axis here, you want less clutter. I'm going to keep the detail. So we'll go to X and turn off the values. And so that is looking good. Now I'm going to copy this and paste it, Control V, and move it. Those red lines are so wonderful. And we need to change it from customer to region. So we'll get rid of Y-axis, add region, go up to Format, General, Title, and we'll change it to region and enter. Now this is looking spectacular. If I click Apple, there's my useful information for customer, region, and time. Now these visuals interact. If I select this column, let's say East, well, I definitely like what it did here. But over here, this is called highlight, and it is nice sometimes. But I'm going to change it. I want to just see filter. So I actually see the column for 0.17 mil and 0.08 mil. Since I want to control this chart and how it interacts with others, I'm going to select that chart, Format, Edit Interactions. And for this chart, I'm going to say just filter. I'm going to do the same thing to this. Come over and say filter. If you don't want it to change at all, you use the circle with the no line. So now when I select East, I see everything. When I select West, this is filtered, and everything is updating. Now I'm going to Control S. That's our product dashboard. Now let's go over and create our region dashboard. All right, we're going to start this regional dashboard with a clustered column. We want to drag down into the horizontal axis product. We want to show the height, total sales. Down here for tooltip, we're going to drag all the other measures, cost of goods sold, gross profit, and average daily sales. Now, here is something spectacular. But if we scroll up, multiples, if we drag customers down to multiples, bam, we get 4 for the price of 1. Customer 1, 2, 3, and 4, each showing product and total sales. And if we hover, there's the cool tooltip. Now let's remove the product horizontal and the total sales vertical labels. Format, we'll go to X, scroll down, uncheck title. And for Y, we're not going to have values or title. I want to show data labels, so we'll scroll down, turn them on. let's open this up and show them, not auto, but inside end. And of course, that is chart junk. So we'll come over to General, Title. We'll say Product Sales by Customer. So that is looking good. Now we want one of the new slicers. By the way, watch out for this. If you have this selected and then click something, it converts it. Control-Z to undo. So click in the white, New Slicer. We want Region, over to Format, Layout. Let's do single row. We'll resize it. And then down here for buttons, we'll do Fill, maybe some blue. That is looking good. Now here we want a clustered column, Product and Region. So click in the white, Clustered Column, Product, Total Sales, and then we'll drag Region to the legend. Well, if we have this up here, maybe we get rid of the X and Y labels. So we'll go to the Format, X, no title, Y, no title. And then we can move everything around, make it neat. And I think I like the interactions the way they are. No need to edit. So East, and just like that, this one shows only East, but bam, product sales by customer in the East. Here's the Midwest. And we'll click to turn it off. Now in this Power BI desktop file, we created a regional dashboard, a product dashboard, and we created a data model. Now we're going to publish this, and we're going to publish it to Power BI Online Services. Now Power BI Online Services and other online tools like Power Query Online, Dataflow, those are only available in enterprise packages that businesses or entities like where I work, Highline College, they buy an enterprise package from Microsoft. Individuals do not have access to it. So not everyone in the world is going to use Power BI Online. But for any large entity that needs to collaborate, it is an amazing tool. Now for BI 348 Spring 2024, I've created a specific workspace up in Power BI for us. You can access this workspace through your Highline College credentials. Now before we publish, we're going to F12 to save as. And we're going to change the name. So your name is in the file name. All right, I'm going to click Save. And now when we publish, the two tabs with our reports and visualizations and this data model, which will be converted to a semantic model, will be published. Now, we call this a data model, but when we publish it online, you'll see that they call it a semantic model. And the two models are exactly the same, except for two things. When we publish this online, it becomes an online data source, a single source of truth that is available to those who have access to the workspace. The other difference is that you can have security measures for reports, visuals, models, and data. Now I'm going to click Publish. It wants to know which workspace. I'm going to say our workspace for Spring 2024. Select. It's publishing. Now you can jump over to Power BI Online with this link. You can go directly to powerbi.com. Or my favorite method, since I'm always in Outlook and I always have it open, I just go to the Apps and click Power BI. Now here's our workspace, but on the left, you can go to Workspace, and there it is. I'm going to click to open it. I've set it up with a bunch of folders. However, these folders are in beta, and I haven't figured out yet how to directly publish to that folder. Let's come down to the semantic model and click the ... options and move it to week 1 and 2. Move. Same with this. Now we can go look in week 1 and 2. Now we have two objects in our workspace, a report and a semantic model. If we click on the report, it's fully interactive, just like over in Power BI Desktop. We can click Share. You can copy the link and send it to someone, email it to someone in your organization, Teams, and PowerPoint. We can use the Edit button to get to our visualization tools. To get back, we click Reading View. Now notice we have our 3 tabs, but if we want to publish this one tab from our Power BI desktop file, we can publish it as a dashboard. over here, options, pin to dashboard. I'm going to create a name. I'm going to put my name in product dashboard, pin live, go to dashboard. And there it is, fully interactive. And if you want to share it, you can share up here. Now, if we go back to our workspace and then back to the actual workspace, not the folder, oh, our dashboard didn't go to our folder. Well, we're going to move it. Now, if we go look at the semantic model, well, we're not going to see it like we did in model view. But you can, from this semantic model, create a blank report. That's like a Power BI desktop file. Share the semantic model. But more importantly, if we're in Excel or Power BI desktop or other Microsoft tools, if we're logged in, we can access the single source of truth. Now, I opened up a brand new Power BI desktop file. We're going to go to Get Data. And there it is, Power BI semantic models. When I click, you can search for whatever data model you have access to. I'm going to select this one. And when I click Connect, it is not going to import anything at all. In fact, if you go over and look here, wow, there's the full model. Well, at least a live connection to it. Look at this. There's not even a table tab because nothing's imported. We are just connected live to a single source of truth. So we can come over here, create whatever visual we would like, and bam, we can analyze connected to the single source of truth semantic model. Now, next, we want to go back up to Power BI Online and look at Dataflow. Now, for our last example for this epic video, we're in charge of some on-premises files, and we want to bring them into Dataflow, transform them into a single table, and then store it in the very same tool, Dataflow, so the people who have access to the workspace have a single source of truth. All right, in our workspace, we're going to click the drop-down for New, Dataflow. We want to add new tables. This is Get Data. Let's choose Text. And we're going to upload. It will upload it to SharePoint, which is an online location to store data. Let's browse. Wherever your source data is, we're going to double-click Text. And this file path in an online SharePoint location is what is replacing an on-premises path. So whoever gets this, as long as they have access to the workspace, there'll be no problem with the file path. Now we click Next. We're going to make sure it's a tab. Click Transform Data. This looks just like Power Query. And here's Online Power Query. I called it F, Product Customer Sales. Now we need to go get our Excel data. So Get Data, Excel Workbook, Upload, Browse, double-click. We'll click Next. In Excel and Power BI Desktop, it says Navigator. Here it says Choose Data. I only want Customer and Product. Click Create. The name dCustomer and dProduct are fine. Over in our fact table, we want to do a merge. So under Combine, Merge Queries. We're first going to go get attributes from the product column. So dProduct, product ID, click OK. Let's expand. We want product and price, click OK. Next, we want to merge with customer. So combine, merge. There's customer ID, the foreign key. We'll go to the dimension table, primary key, click OK. We'll click expand, unselect all. I want discount and customer, click OK. Now we need to calculate sales, and we'll come back and deal with discount in just a moment. Let's select price, scroll over, hold Control, click units, and just like Excel Power Query and Power BI Desktop, add column, standard, and multiply. We're going to double click and rename the column, something like net sales, and enter. Now we have net sales, but we need to take into consideration the customer discount. Now the problem is that % symbol, if we put it in field access operators, would require the pound and double quotes. So I actually want to change this name. But instead of adding a step, let's go back to the previous step, which I already renamed. Table.expand table columns, well, it allows us to name the two columns. So I'm going to change the name to % discount, no space, no symbol that's not allowed, and enter. So now we can see that there. We'll come to Calc Net Sales. And we can't just take the discount and multiply it by net sales, because that would give us the discount amount. Remember, this represents 5.75% discount, or 5.75 pennies for every $1 paid. So what we really want is 1 minus the discount. That means instead of 5.75, this will be 94.25. And that's how many pennies this customer paid for every $1. So up in the formula bar, times in parentheses 1 minus, square brackets. And this is where I get into trouble because I'm a bad speller, but let's try it. 1 minus % discount, and check. And there we go, the correct net sales amount. Now let's round this. I don't want these extra pennies. In Power Query, the round function is different than in Excel and DAX. It actually does bankers rounding, which is more accurate when you have lots of numbers. But let's use the function number.round, open parentheses. And so then all of that is going to be inside. And then comma 2, that's the second argument in number.round. And then close, click the check mark. Now we have our net sales. Now we're ready to keep the columns we want to go in our data flow and remove the ones we don't want. We want date, units, holding control, product name, customer, and net sales. Right click, remove other columns. Now I want to change the name up here and preface it with your name. I'll put my name. And product and customer are just up here in the editor to help us get the flat table. So right click, and like in Power BI Desktop, we uncheck enable load. This is like connection only load in Excel. All right, now we're ready to save. Notice in Excel it says close and load to. Power BI Desktop it says close and apply. But here, save, saves it to the workspace. Close, closes the editor. So save and close. All right, I created a name and a description. Now I'm going to click Save. I'm definitely going to click Refresh now just to keep it refreshed. If you need to come and edit later, there's the Edit button. Now we can close the editor. And now we're back to our workspace. And sure enough, now we have a data flow. Now over here in the Excel file, we can go to Data, Get Data, from Power Platform, and there it is, Dataflows. Notice it has an S. The tool is without an S, but when we go and get data from there, it has the S. We're going to navigate to the workspace. And sure enough, there it is. Now we can say Transform Data. There it is. We're going to close and load to Pivot Table on the existing sheet. Click OK. Now this data is loaded here. It's a single source of truth up from Dataflow, but we actually got the data, which is different than the semantic model. We can check product and net sales. All right, this was an epic video. 7 examples of how to use Microsoft Power Tools. We started it off in the worksheet with pivot tables and worksheet formulas. We saw how to create a straight Power Query solution. We used Power Query to load it to the PivotTable Cache. We saw Power Query with Power Pivot and DAX. We did a Power BI Desktop solution. We uploaded it to the Power BI services. And finally, we had fun with Dataflows. All right, we'll see you next video.